Hello everyone. Today let's solve the problem number 10, regular expression matching. So what the question states here, we need to implement a function that matches a given input string S with a pattern P. So P has to match S here, right? So we need to implement a function that matches a given input string S with a pattern P, right? So the pattern supports two special characters. One is here, the pattern supports two special characters, star and dot. So what does dot say here? Dot means it matches any single character. You can clearly see here, matches any single character. It may be of any character, it doesn't matter, it matches the any single character. And star, it matches 0 or more of the preceding element. So it matches 0 or more of the preceding element means if the element is if the previous element present here, if we are considering, suppose if we are having a here, this one, if we consider, if the first element here, this one, if we give a star, then star is nothing but here a is repeated once more. That's what the star represents here. Means star means here 0 or more of the preceding element a. They have clearly mentioned here. Therefore, by repeating a once, it becomes AA, right? So here star matches 0 or more of the preceding element and dot matches any single character. That's what they have given. Any character it might be, it matches any single character they have given here, right? So I hope the question is completely clear. Let's come to the example 1 here. So in the example 1, they have given AA and P equals a pattern A they have given, and S a string AA they have given. Here it is false because we have only A in the pattern and A does not match the string. Means pattern does not match the string AA, right? So here we have to return in this case false. So in example 2, we have AA and A star. And star, here they have clearly mentioned, we have already discussed this one. Star means 0 or more of the preceding element A. So we can consider this one AA. This matches A. Star represents the preceding element, right? 0 or more of the preceding elements. We can consider A here. AA equals AA. Therefore, by repeating A once, it becomes AA. So we will return true in this case, right? So the third one here, S equals AB and P equals dot A. So here dot represents matches any single character, right? We can just consider here any character AB. So this one here, star means 0 or more of any character. Any character it might be, right? So here in this case, for dot we can consider A, and for star we can consider B here. So right, so this will be AB equals AB in this case. So we have to return true in this case, right? So I hope the question is completely clear in this case. So what we'll do, initially let's discuss the approach followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, let's discuss the approach. I'll just consider the first example that they have given in the question so that it will be easier to understand, right? Let's start discussing the approach. So here, let's discuss the approach step by step. I have considered the first example that they have given in the question. So we have to keep in mind that we will be going with the dynamic programming approach, or we'll be going with 2D DP. So we'll be going with 2D dynamic programming or 2D DP, right? So here I have considered the same question, first question that they have given in the question. A does not match any string A here, right? So we have to return false in this case. We have already discussed this one. Let's see the approach here. So step 1 here, let's understand what we will do first, then let's go with the DP table implementation, right? So first thing is we are going with the 2D DP. We know this one. We will be creating a 2D DP table where DP of ij represents whether the substring matches the pattern or not. You can clearly see in the table itself, right? P is nothing but pattern, S is nothing but string. So we have considered 2D DP table where substring, whether the substring matches the pattern or not, we have to check, right? So let's see this one. So what we will do, first we will initialize a m+1 into n+1 dp table. So here for the easy computation, we will initialize m+1 into n+1 dp table, right? Hope this is clear, right? M is nothing but length of the substring and n is nothing but length of the p. In this case, length of the substring is 2 here. You can clearly see here. Yes, length of the substring is 2 here and length of the pattern is 1 here. We have only one character length we are considering, right? 1, it is 1, 2. This is 1. I hope this is clear. In this case, length of m is nothing but s dot length substring 2 and n equals 1 in this case. N is nothing but length of the pattern here, right? dp of ij will store true if substring matches pattern. We know this one. Substring, if the substring means here this one, substring s. If m matches n, then dp table will return true. This one we have to keep in mind, right? Initially we have initialized the dp table, right? So here let's fill the dp table. Before filling the dp table, so let's try to understand certain things here, right? So if the character matches, means p of j minus 1 equals s of I minus 1, or p of I minus 1 equals dot here. So in this case, p of I minus 1 equals dot here. Then what we'll do, dp of ij equals dp of I minus 1 into j minus 1, right? We saw that one in the second example. A equals a star. This also matches, right? Because star is nothing but it matches one or more preceding character, right? So this one. So dp of ij equals dp of I minus 1 into j minus 1. That one we need to consider for the this one. What do you call? Uh, Star. For the dot, if dot is present, then character matches p of j minus 1 equals s of I minus 1, or p of j minus 1 equals dot. Then we will consider, then also we'll consider dp of I j equals dp of I minus 1 into j minus 1, means it matches, right? Second and third example, equivalent to second and third example. This we will come to know when we write the code. Let's start filling the dp table first. So here dp of 0 0 here, this one, dp of 0 0 here is true. So why it is true here? Empty string matches the empty string, right? So that is the reason we will get true in this case. This matches, empty string matches empty string here. So this will be empty string doesn't match a, right? So in this case it will be false, right? Empty string doesn't match a here, right? This is fine. So a matches empty string, no, this is false as well in this case. 1 comma 0, for 1 comma 1, dp of 1 comma 1 is true because a matches a here, right? In this case it will be true. So a we have here, so a doesn't match the empty string, this is false, and a doesn't match the a as well, this will be false as well. So this is the final dp table, right? We got here. So in this case, dp of 2 comma 1 is false here, you can clearly see. So always when we consider the this one 2d dp table, we will return the last value that is present in the last cell. We'll return the value that is present in the last cell or the bottom right cell, right? So in this case, we have false. dp of 2 comma 1 is false. So what we will do, we will return false here. Since dp of 2 comma 1 is false, we will return false in this case. So the output that we need to get is false, and the output that we got here is also false in this case. So the this one, the approach works absolutely correct in this case, right? So this is the approach that we will be going with 2D dynamic programming. We saw the 2D DP table as well, and we discussed certain things, two cases, right? When we have dot, when we have star. So that one we try to implement that one in the form of code, or we try to articulate that one in the form of code later. Now, for now, this is the approach that we'll be going with. We should keep in mind this one, and also let's discuss some edge cases so that it will be easier to write the code, right? So the first edge case that we'll be going with here is S equals A B I have considered, C equals C star A star B I have given. In this case, it will be true, right? So we have star here. So here C star is ignored. In this case, C star is ignored. A star matches AA here. This one, A star matches AA. You can clearly see here. And B matches B here. You can clearly see here. This one is ignored here. And A star matches A and B matches B. So the output will return here as true. So let's go with the second example here, Mississippi. And P we have here this one star. So output will be false in this case. Because in this case, P star cannot match this one, cannot match SSI, PPI, this one. SSI, PPI, this one. P star doesn't match here, SSI, PPI. So the output will be false in this case. So let's go with the third example here, or the third edge case here. This one is empty string and this one is dot star here in this case. So output will be true in this case. So why the output here is true? Because dot star matches 0 occurrences of 0 or 1 occurrence of any character, right? Here, this one, dot star. We have already seen this one in example. So the output will be true in this case. And the fourth edge case here is S equals ABC we have and P equals ABCD we have. So here ABCD expects an extra D, right? Here this expect P. Here we expect extra D in substring, right? So which S does not have. In this case, we will return false. So these four edge cases that we need to keep in mind here, right? So these are the four edge cases that we need to keep in mind here. And we already have seen the approach. So I hope the edge cases as well as the approach that we discussed is completely clear. So now let's start writing the code here. So we'll be making use of length of the substring as well as length of the pattern here. So let's assign that one to some variable. So we don't have to write length of the S every time and length of the pattern every time, right? N equals P dot length. I hope this is clear. The next step here is we will create the DP table, nothing but 2D DP table, right? So here DP equals array of m plus 1 and n plus 1. We have already discussed this one. Let's make use of fill here. Let's go with map here. In this case, this one will be array of m we have already considered for rows and n we will consider for columns. So let's fill this one initially with false, boolean value false. I hope this is clear. The next step here is base case. So what was the base case we discussed? Empty string always matches the empty pattern. We saw that one in the DP table as well. So we can write here DP of 0 0 is always true. So we have seen this one in the DP table, right? So the next step here is handling patterns with star at the beginning. If we have star at the beginning, right? Star means here you can clearly see matches 0 or more of the preceding element. We have considered this one, right? So handling pattern with star at the beginning. So how can we articulate that one in the form of code? Let j equals 1, j less than or equal to n. Increment the j here. If p of j minus 1 that is equal to star, then what we will do? dp of 0 j, we will give here dp of 0 into j minus 2. This is fine. We know that star can eliminate the preceding element, right? So that is the reason we have given here dp of j equals dp of 0 into j minus 2. So I hope this is clear. This we already saw in the approach. So let's iterate over the string and let's iterate over the pattern. We have to iterate over the individual characters in the string and individual characters in the pattern, right? So two for loops for this one, string and pattern. So let I equals 1, I less than or equal to m. Let's increment the I here. This is fine. For let j equals 1, j less than or equal to n. Let's increment the j here. This is fine. So let's consider the first case here. The case when characters match dot. So when we have dot here, so when dot is present, we can say. So this one I have already said this one during before filling the dp table. So dp of ij equals dp of I minus 1 into j minus 1 when we had dot. Case 1 we discussed, if you remember. So else case 1 we will ignore star and preceding character. So this is for the dot, previous one was for the dot, right? When characters matches with dot, right? So this is when this one star matches the preceding character. So when we ignore star and preceding character, right? So how can we write that one? This one is a bit tricky, so I'll just write here in this case, else if p of j minus 1, this one pattern, this one equals star, we are comparing, right? If we have star, then we can articulate in the form of code in this way: dp of ij here equals dp of I j minus 2, or we can consider substring of I minus 1 here equals pattern of j minus 2. So why we are considering j minus 2, we know that one, right? So we have already discussed this one. So equals dot here, and we will consider dp of I minus 1 j as well. So this one dp of I minus 1 into j. I hope this is clear. We'll be using star, right? If there is a match. We'll be using star if match means suppose if we are making use of star, suppose if we have aa and a star, we saw that one in the second example. So preceding character we will consider a itself, a as the next to first a, so aa will be aa itself. So it matches in that case. So the second example here, this one I'm speaking of, sorry, I should have shown this one directly. Yeah, aa and a star, this one we are speaking of, right? So in this way we can articulate that one in the form of code. The final step here is we have to return the final result. In our case it is dp of mn, as always, as we are going with rows and columns are 2d dp here, dp of m and n here. So I hope this is clear. This is it for the code. Let me format the code once and let me hit the run button. I hope this works. Let's see. Else problem we have here. Else if unexpected token, else we haven't made use of if here. I minus 1 and oh yeah, here what I have done here is I have missed one thing here. I have missed one condition here. Still showing. Just give me a second here. So here there is one condition we have to go with in the line number 13. So I missed this one. If p of j minus 1, if it is equal to dot, so this one I had to give, right? So dot and star are the two cases that we need to consider here. Dot or substring of I minus 1, that is equal to, we are comparing with p of j minus 1 here in this case. This one I forgot, so I hope this works now. Let's see, let me hit the run button. So we have a wrong answer here. What answer we are getting here? Output is false. We need to get true. Let's check what. So here what mistake I have done here is in the line number 16, instead of triple equals here, we are not comparing here. Either we are considering substring of I minus 1 or p of pattern of j minus 2 equals dot, right? So this one. So here this has to be R. So let me hit the run button again. I hope this works. Let's see. So yeah, now you can clearly see the sample test cases are getting passed here. So the code works absolutely correct in this case. Let's see. Let's hit the submit button quickly. I hope the code works. Let's see. Wrong answer we are getting. 305 out of 354. So somewhere we have done wrong. Let's see. This test case is failing, right? So here this itself I have done wrong. S of I minus 1. This one first we have to compare with p of pattern of j minus 2, or pattern of j minus 2 equals this one we are comparing with dot. So this one has to be equals to p of j minus 2. We have to compare with a pattern of j minus 2, right? Let me hit the run button again. Let's see. So let me quickly hit the submit button. Let's see whether this works or not. Yeah, now you can clearly see all the test cases are getting passed here. So the code works absolutely fine in this case. So let's quickly discuss the complexities for the code that we have written. So here the approach that we went with here is dynamic programming, or 2DDP we can call, right? So the time complexity here would be, the overall time complexity here would be because of m into n here. So why it is m into n? Because we are iterating through the string and pattern. You can clearly see we are iterating through the string and pattern, right? So what would be the space complexity here? The overall space complexity would be because of m into n as well. Let me give here because of m into n. Why it is because of m into n here? Because we are making use of a dp table of size m plus 1 into n plus 1. You can clearly see here we are making use of dp table of size m plus 1 into n plus 1. So the overall space complexity would be because of m into n as well. So the time complexity and the space complexity for the code that we have written is big of m into n. I hope the solution or the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.